Question 1. 60 students were asked to draw a 20-degree angle without using a protractor. The size of each angle drawn was measured, and the results are summarised in this box plot. So first of all, we're asked to work out the range. To work out the range, you would need to know the highest angle anybody drew, which is up here, 48, and we need to subtract the lowest one that anybody drew, which is here, 9, and that gives us an answer of 39 for 1 mark. Part B says find the interquartile range, which we do by finding Q3 and subtracting Q1. It's the gap between these upper and lower quartiles. Q3 is 25 and Q1 is 12, giving an interquartile range of 13 for the 2nd mark. Then it says the students were asked to draw a 70-degree angle, and the results this time are given in a table. It's a grouped frequency table, so we don't know the exact data, but we do know that 6 children drew angles that measured between 55 and 60 degrees, 15 kids drew angles that measured between 60 inclusive and 65 degrees not included, and so on. Then it says use linear interpolation to estimate the size of the median angle drawn. So there were 60 kids, and because we have this group frequency, we just do 60 divided by 2 and say that we're looking for the 30th value. So we have to think this data has been organised from smallest angle to largest, and we want to come 30 steps through the data. So we've got 6 kids who drew angles up to 60 degrees. Well, 6 doesn't get us to the 30th. Then we've got another 15 kids who measured angles up to 65. So far together that's 21 kids. Again, we haven't reached the 30th value yet. But by the time we include these next 13 children who drew angles up to 70 degrees, that takes us to 34. And we now have passed the median. So that means that the median lies somewhere in this class, definitely for sure, and we can estimate the median value using interpolation. So we draw a diagram, like so. We say that the class runs from 65 to 70, so we know the median is somewhere inside here. And at the start of the class, there were 21 kids that had angles below 65, so up to that point. And by the time we get to the end of the class, we've included 34 students. And we said that the median's the 30th, what the 30th kid was up to. So the 30th is going to be slightly further this way. And this missing number that we're looking for is the median, so I'm going to label it Q2. Now there are different ways to find Q2, but the way that makes most sense to me is to say that we know the number's higher than 65, so we're going to start at 65, and we need to add on something. Very particularly, we know the size of this gap is 5, so we need to add on some fraction of 5. We want to come some fraction of the way through this class. And how do we work out what fraction of the way through? We look at these numbers. So we've got a gap of 9 here, and we've got a gap of 13 here. Of course we have a gap of 13 here because there were 13 students in this group. So as a fraction, what fraction of the way through this are we? We are 9/13 of the way through this class. So this will work out the value for Q2 for me. So I just need to go to the calculator, 65 plus 9/13 of 5, and I get 68.461538, and so on. Let's put the dots on from the calculator. And do we have any instructions? They want 1 decimal place. So this is going to be 68.5 degrees because it's an angle to 1 dp. Part D says that we need to show that the lower quartile is 63. So for the lower quartile we need 60 divided by 4 now, which is 15. So we need the 15th value. And we can tell that the 15th value is not in the first class because that only includes 6 people. But by the time we include these extra 15 people, we've got to 21 people now. We've passed the 15th person. So we're going to be looking in the second class. So I'm going to repeat the diagram from before. We're going from 60 this time to 65. At 60, there were only 6 children with angles of that size, but by the time we get to 65, we've now included 21 children. This is a gap of 15. There are 15 children in this class. And we're looking for the 15th value, so that's going to be somewhere over here, slightly nearer to 21 than to 6. And this missing number that we're after is the lower quartile Q1. To find Q1, we start from 60 and we need to come some fraction of the way through this class, which is 5 wide. Oops. So what fraction? Well, we look to see how far is the 15 into this class compared to the 6, so that will be 9. So this 15 is 9/15ths of the way into this class, and whatever 9/15ths of 5 is, that's how far we need to come into this section. You can put that in the calculator. This can actually nicely be simplified, but I'm just going to put it into the calculator and get 63. And because it said show that's the value of the lower quartile, I'm going to put QED here to say that I understand that I've proved it. Sorry for hiding that writing. Okay, next up, for these data, the upper quartile is 75, the minimum is 55, and the maximum is 84. An outlier is an observation that falls either more than 1.5 times the interquartile range above the upper quartile, or more than 1.5 times the interquartile range below the lower quartile. So we've got to show that there are no outliers for these data. Okay, so E, part I. So we need to do 1.5 lots of the interquartile range above the upper quartile. So the upper quartile is 75, and we need to go above it, so we're going to add on 1.5 multiplied by the interquartile range, which will be the upper quartile, minus the lower quartile, which we were just told to show is 63. So when we work that out, we get 93. Now we're told here that the maximum is 84, so there are no values above this. Okay, now let's try to find the lower bound for our outliers. So this time it says we need to go below the lower quartile. So the lower quartile was 63, and we need to go below it by 1.5 times the interquartile range. And so this time I get 63 minus this, and I get 45. Now it says that the lowest angle drawn was 55 degrees, so there are no values below this, and we conclude from all of this, therefore there are no outliers. Make sure you've really shown that you've answered the question that they asked. Show that there are no outliers. Clearly done. Part 2 says draw a box plot for these data on the grid. So what you would do is on the grid that's given in the test, you would mark the lowest value. There's no outliers, so you don't need any crosses. So we mark the lowest value at 55, the highest value at 84. The median that we worked out by interpolation in part C goes at 68.5. The lower quartile is 63 from part D. And the upper quartile is 75 as stated in the information from the question. So quite a nice easy few marks there. Okay, and then part F says, state which angle the students were more accurate at drawing and give reasons for your answer. So at that stage, you want to compare these two situations. This is the box plot for the 20-degree angle, and this is the box plot for the 70-degree angle. Now, if you look at that, you can see that the median was 4 degrees off from the value they were supposed to be drawing, the angle size they were supposed to be drawing. And on this one, for the 70-degree one, the median was only 1.5 degrees off. So this one looks more accurate. They will want you to comment on more than just the median. Whenever you're asked to compare distributions, you should make a comment about spread as well. So you could compare the ranges. The range for 70 degrees is much smaller than the range for the 20-degree drawing, because from the cross to here, this is much bigger than this one. And also the interquartile range is marginally smaller on the 70-degree one than the 20-degree angle. So you can write a concluding paragraph, something along the lines of this. The 70-degree angle was drawn more accurately as the median was only 1.5 degrees from 70 degrees, whereas the 20-degree drawings were 4 degrees away when using the median value or measure. Also, the interquartile range was smaller for the 70-degree drawing than the 20-degree drawing, and to be extra safe, I could have not put a full stop there and written, therefore, also showing that the 70-degree angle was drawn more accurately.